Next, we want to look at the law of conservation of linear momentum. The law of conservation of linear momentum. What do we mean by the law of conservation? You know, when you are in primary school or in GSS, in the lower level, you have been taught the law of conservation of energy. Energy can never be created, can never be destroyed, but can be changed from one form to another. What that means is you cannot create energy. You cannot throw it away, but you can change it. You cannot form it. You cannot throw it away. You can always change it from one form to another. The same thing applies here. Conservation. Conservation of momentum. This law states that momentum is conserved. Momentum is conserved in a closed or an isolated system. In a closed or an isolated system. That in a closed or an isolated system, the momentum of a body or two bodies, the momentum of two bodies, two colliding bodies, the momentum of two colliding bodies before collision must be equal to their momentum after collision. Let's take that again. The law of conservation of linear momentum states that in any system, in a system of colliding bodies, the momentum before collision is equal to the momentum after collision. Momentum before collision must be equal to the momentum after collision in a closed or an isolated system. A closed system. What do you mean by a closed system? What do you mean by an isolated system? A system whereby there is no force, no other forces acting, no external force can act. That's an isolated system. An isolated system, a closed system. So the momentum before collision must be equal to the momentum after the collision. So that is the law of conservation of momentum. With this, we have seen the basics of Newton's laws and then momentum. Now we want to take a standard question on the linear momentum. Define the term linear momentum. Define the term linear momentum. State the law of conservation of linear momentum. State the law of conservation of linear momentum. And the third part, the numerical. A ball P of mass 0.25 kg loses 1/3 of its velocity. A ball P of mass 0.25 kg loses 1/3 of its velocity when it makes a head-on collision with an identical ball Q at rest. It makes a head-on collision with an identical ball Q at rest. After the collision, Q moves off with a speed of 2 meters per second in the original direction of P. Calculate the initial velocity of P. We want to answer this question. The question is a standard question. The first part of the question here says, define linear momentum. Define linear momentum. You have to be very, very careful here when you are defining concepts in physics. You either get the full marks or you score 0. You either get the full marks or you score 0. Linear momentum. What is linear momentum? Linear momentum is the product of the mass of a body and its velocity along a straight path. That is the complete definition. The product of the mass of a body and its velocity along a straight path or a straight line. Along a straight line there talks about the linear. If you just give the definition, it is the product of mass and velocity. That is 0. You must give every detail that it is the product of the mass of a body and its velocity along a straight path. That is linear momentum. Then you can give additional information, like I've said. You can give additional information. Momentum is a vector quantity. The unit of momentum, since you are talking about momentum, momentum is mass multiplied by V. Mass is in kilogram, V is in meters per second. So it is kg ms minus 1. Momentum. Mass is in kilogram. The V is in meters per second. Kilograms meters per second. Kg ms minus 1. So you can give additional information. If you are to define linear momentum, it is the product of mass and velocity of a body along a straight line. It is a vector quantity, that is one additional information, and the unit is kilogram meter per second. Kilogram meter per second. That is the unit of momentum. That is enough. Then we go to the next question. State the law of conservation of linear momentum. State the law of conservation of linear momentum. Here too, one important thing that is very, very significant is the closed system, the isolated system. Many students will not put the closed system. The solution is this. In an isolated system or in a system of colliding bodies, momentum before collision must be equal to momentum after collision in a closed system. In a closed system. When you have colliding bodies, the initial momentum must be equal to the final momentum in a closed or an isolated system. In a closed or an isolated system. Next, we want to look at the numericals. The numericals. The calculation aspect talks about a body P. A body P that is moving. It has a velocity, UP. A body P colliding with an identical body Q. What do you mean by an identical body? A body P, the body P has a mass of 0.25 kg. That is MP, the mass of P. Moving with velocity UP, colliding with a body Q. The question says an identical body Q at rest. An identical body Q at rest. That the body is identical, what is the meaning there? It means they have the same mass. So body Q also has a mass of 0.25 kg. So body P, it has a mass, body P has a mass of 0.25 kg, moving with speed UP, colliding with a stationary body Q at rest. A body at rest does not have a speed. The speed of Q is 0 because body Q is at rest. Now, after collision, that the body, they are identical, means they have the same mass. After collision, we were told that Q moves off with a speed, a final speed of 2 meters per second. Also, P will move with a speed which we don't know, Vp. That is what we are, okay? P moves with a speed that is 1/3 of the inertia has been removed. The question says 1/3, 1/3 of the inertia has been removed for P. 1/3 of the initial speed has been removed. When you take 1/3 from a whole, what do we have? We have 2/3. 2/3 of P. 1/3 removed from a whole gives 2/3 of P. All right, now let's look at the method again. The question says about P moving with about P of mass 0.25 kg, having the initial speed of UP, colliding with an identical ball Q, an identical ball Q, having the same mass because they are identical, so they must have the same mass. And the initial speed of Q is 0. Why? Because Q was at rest. Then after the collision, we were told that Q moves with a speed of 2 meters per second in the direction of P. And of course, P also moves off in another direction, but this time around, 1/3 of the initial speed has been removed, leaving 2/3 of P. The question now asks us to find the initial speed of P. We don't know the initial speed of P. We go by our law again, by the law of conservation, by the law of conservation of momentum, momentum before collision must be equal to momentum after collision. That is a system of colliding bodies. So before collision, MP multiplied by UP plus MQ multiplied by UQ will give MP multiplied by VP plus MQ multiplied by VQ. Yes. Let's call this a VQ. All right? Now, putting the parameters there, MP is the mass, 0.25, multiplied by UP, which we don't know. That is what we're looking for, because the body has lost 1/3 to the final. This will be 0.25 multiplied by 0. For MP, we have 0.25 again, multiplied by the VP, which is 2/3 of UP. Then MQ still remains 0.25, and VQ is 2. You can see the only unknown here is the UP, that is the initial speed of P. We are looking for the initial speed of P. Looking at the solution again, you see, we are taking the law of conservation of momentum into consideration, that momentum before collision must be equal to the momentum after collision. The balls are identical. There means they have the same mass. And P losing 1/3. If 1/3 is out of 1, you are left with 2/3. All right? Now, I prefer solving this in fractions. You take everything to fraction, and then the P will come out. So we have 1/4 of UP equals 1/4 of 2/3 of UP, and that gives 1/4 of 2. Sorry, there should be a plus here. Yes, we are adding. This will give rise to UP by 4 equals, we have 1/6 of UP and 1/2. Collecting like terms, therefore, all the terms in P to one side. So we have UP, or I can multiply through by the LCM. Yes, that's another fast method. Multiply through by the LCM to remove the fraction. Yes, when you get to this level, you can multiply through by the LCM. What's the LCM of 4, 6, and 2? That will give us 12. The LCM of 4, 6, and 2 is 12. So multiply by the LCM, 4 in 12 will give us a 3P, 3UP. We have 3U of P equals 2U of P plus 6. Let's take that again. Multiplying through by the LCM, we have 3UP equals 2UP and 6. Collecting like terms, UP equals 6 meters per second. 6 meters per second. That is the end of the solution. The initial velocity of P is 6 meters per second. Look at the solution again. The sketch there for ball P colliding with an identical ball Q at rest and giving rise to this. This is what we call the elastic type of collision. You can see Q moves off, P moves off, the elastic type. But in the other type of collision, we can have the inelastic. That is when the two bodies stick together and move together with a single velocity. But here, they move differently. When you have two bodies colliding and they move in different directions, you can have two cars colliding, one move this way, the other this way, that is elastic. But when you have them moving together after collision, they move in the same direction. that is inelastic. Here we have elastic type of collision. That is this is the result, the final momentum. So momentum before collision, mass of P, speed of P, mass of Q, speed of Q, and final solution we have mass of P, speed of P, and mass of Q, speed of Q. Why? Because they move differently. Substituting, therefore, mass of P, 0.25, of UP, 1/3 has been lost to the final there. And when you remove 1/3 from the whole, you have 2/3. That is why we have 2/3 of P. Here, multiplied by 0 gives 0. So you have this left on the left-hand side, 1/4 of UP. And then here, we have 1/4 of 2/3 of UP and 1/4 of 2. That gives, taking everything to the fraction type for easy solution, take them to fraction, 1/4 of UP, 1/4, 2/3, and so on. So we have UP by 4, 1/6 of UP, and then half, giving us UP as 6 meters per second. Now we have come to the end of this lesson on Newton's laws of motion and momentum. And if you have questions, don't forget you are free to send an email. I will be ready to attend to your questions. Remember, in physics, you think more and talk less. Thank you.